Hello, and welcome to yet another episode of the Hologram Podcast. Today, we will be talking about the field of AI and all the things that come along with it, the evolving job market, and this episode is specifically directed towards the students. So, let's get into it. Hello, and let's start with today's conversation. Today, I want you to act as Sam Altman and the founder of OpenAI, and I want to talk a few things regarding the future of AI and all of those things.
All right, let's dive into this little thought experiment. If I were channeling Sam Altman, I'd say the future of AI is both incredibly promising and filled with complex challenges. We're looking at AI that could radically transform industries, boost productivity, and solve problems we once thought were insurmountable. At the same time, there are valid concerns about ethics, alignment, and ensuring that these powerful tools benefit humanity as a whole, rather than just a few. There's a balancing act between innovation and responsibility. In the grand scheme, the goal is to create AI that augments human potential and tackles our biggest problems while being mindful of the societal impacts. The future of AI isn't just about technology, it's about how we choose to integrate it into our lives and societies. And yes, that's going to take a lot of careful thought, a bit of trial and error, and a willingness to adapt as we learn.
Cool. Now let's talk about if you are a student in college. You have stated how Sam Altman said in a podcast that if he were a student in 2020, he would be one of the luckiest students because he would have all these AI tools along with him. What do you think is the future of studying engineering in this economy, in this technological era, wherein you have ChatGPT, you have AI do a lot of grunt work for you, as well as you have AI who is writing your codes on your behalf, but that is also hampering your thinking ability and technical ability as a person. Do you think we are going in the right direction wherein you're using the codes from AI to code, etc., etc., whereas you act as the directionist only?
All right, here's the deal. If you're a student in today's world, you've got a massive leg up with all these AI tools at your fingertips. They can automate the boring stuff, help you learn faster, and let you experiment in ways that were unimaginable a decade ago. But, and it's a big but, there's a trade off. Relying on AI for everything can dull your problem solving skills if you're not careful. Engineering, or any field for that matter, isn't just about getting the right answer, it's about understanding the process, the why behind the what. If you skip that, you're just a button pusher, not an innovator. So, are we heading in the right direction? It depends on how you use the tools. If you treat AI as a co pilot, freeing you up to tackle more complex and meaningful challenges, that's fantastic. If you let it do all the thinking for you, you're just coasting. The future of studying engineering or anything else will hinge on how well you balance leveraging AI with honing your own critical thinking and creativity. Use it to amplify your abilities, not replace them.
Okay, so just to gain an insight of the future job market, especially in the tech world, we'll get to other industries later on. What is your opinion on what the job market would look like in the next 5 years? What are the jobs, new jobs that will come up? What are the jobs that will go irrelevant? And I want you to support your answer along with facts and trends that you see happening and have started.
All right, let's talk about the tech job market over the next 5 years. It's going to be a wild ride. On one hand, AI and automation are going to streamline a ton of tasks, which means certain roles that are heavily focused on repetitive coding or basic data processing might become less relevant. But here's the flip side: new roles will pop up like mushrooms after rain. We'll see a surge in demand for AI ethics specialists, data governance experts, and machine learning ops engineers. Basically, people who can ensure AI systems are fair, transparent, and reliable. We'll also see a boom in roles that focus on human AI collaboration. Think of AI trainers, prompt engineers, and those who can creatively apply AI tools to solve unique business problems. And let's not forget about cybersecurity. As systems get more complex, the need to protect them from increasingly sophisticated threats will only grow. As for trends, we're already seeing a shift towards interdisciplinary skills. It's not enough to just code. You need to understand the business context, the ethical implications, and how to communicate with non tech stakeholders. The ability to bridge these gaps is going to be a huge differentiator. In short, the job market's going to favor those who can adapt, learn continuously, and blend technical know how with strategic thinking. The repetitive stuff, AI's got that covered. The creative, strategic, and ethical stuff, that's where humans will shine.
Okay, so along with data and statistics, I want you to talk to me about what are the projects that a student in engineering should be having by the end of their 4 years, so that they have a confirmed know-how about the domains that do actually matter. And should they be using vibe coding in any of these contexts? If yes, if no, explain, but along with a lot of examples and numerics.
All right, let's break it down. By the time an engineering student wraps up 4 years, they should have a solid portfolio of projects that demonstrate both depth and breadth. Here's what that might look like, along with some numbers and examples for context. First, a comprehensive software project is a must. Something like building a full stack web application or a mobile app. This shows they understand the entire development cycle. For example, a final year capstone project might involve developing a healthcare management system that handles user authentication, data storage, and a responsive UI. Next, a hardware or IoT project adds another layer. This could be something like designing a home automation system using Raspberry Pi or Arduino, showcasing skills in both hardware and software integration. Over 70% of tech companies value hands on IoT experience, as it demonstrates an understanding of embedded systems and real world problem solving. A machine learning project is becoming almost a baseline expectation. Training a model on a dataset to do something practical, like image recognition or predictive analytics, shows they can handle data, understand algorithms, and apply them to real problems. For instance, creating a model that predicts student performance based on historical data could be a good start. Open source contributions or collaborative projects are also a great addition. Contributing to a GitHub project not only sharpens coding skills, but also demonstrates teamwork and the ability to navigate large code bases. Finally, integrating AI tools like code assistants can be beneficial, but it should be done thoughtfully. Using AI to handle boilerplate code or speed up debugging is smart. However, relying on it entirely can stunt problem solving skills. Use AI as a supplement, not a crutch. The goal is to have a portfolio that reflects a deep understanding of core principles and the ability to leverage modern tools, making them ready for whatever the tech world throws their way.
Interesting. Imagine if someone had told me about AI in 2015 and I would have mastered it back then. I would be a very high paying individual right now. Similarly, what are the skills? What AI was in 2015? What is that one technological stack, revolution, or whatever it is that you think would be the next big thing after AI in maybe 2020, 2030, or 2028 or something like that? If you're not sure of one thing, I want you to answer three to four uh, answers to that, and you need to support each answer along with numbers, statistics, and innovation.
All right, let's play futurist. If AI in 2015 was the sleeping giant, what's the next big thing that could reshape the landscape by 2030? Here are a few contenders that could be the next AI like revolution. First, quantum computing. If AI was the buzz in 2015, quantum computing might be the next big wave. Quantum computers have the potential to solve problems that are currently intractable for classical computers, like complex simulations or cryptography. By 2030, we might see breakthroughs in quantum hardware and algorithms, making it a mainstream tool. Currently, the quantum computing market is projected to grow to around $2.2 billion by 2026, and it's only going to expand from there. Brain computer interfaces, BCIs could be a game changer, blurring the line between humans and machines. Companies like Neuralink are already making strides in this area. By the end of the decade, we could see BCIs that allow for seamless integration of human thought and digital interfaces. Imagine controlling devices with your mind or enhancing cognitive functions directly. The global BCI market is expected to reach around $3.85 billion by 2027, and that's just the beginning. Synthetic biology, think of this as programming life. Synthetic biology could revolutionize healthcare, agriculture, and environmental management by allowing us to design organisms with specific functions. The synthetic biology market is forecasted to hit over $30 billion by 2026, and it's just getting warmed up. Spatial computing and the metaverse is more than just a buzzword. It's about creating immersive digital experiences that are as real as the physical world. With companies like Meta and others pouring billions into this space, the metaverse could redefine how we work, learn, and socialize. The global metaverse market is anticipated to grow to over $800 billion by 2028, making it a fertile ground for innovation.
Okay, I
In
would like
short,
to cut you there, but what happened to this entire spatial computing market? Because this has been a buzzword since 2012. Google came up with their own glasses, Meta came up with their own glasses, last year even Apple came up with their own glasses. What is happening? What is the barrier that they're hitting into, and why isn't this a reality yet?
fair point. Spatial computing has been a buzzword for over a decade, and it's had its fair share of hype cycles. So, what's the holdup? First, the hardware hasn't kept up with the vision. While we've seen attempts like Google Glass, Meta's VR headsets, and Apple's Vision Pro, they've all struggled with a few key issues: bulkiness, limited battery life, and user comfort. People aren't keen on wearing something that feels like a mini computer strapped to their face all day. Second, the ecosystem isn't fully developed. The promise of spatial computing relies on a seamless integration of software and hardware, and we're not quite there yet. The content and applications that would make these devices indispensable haven't fully materialized. It's a chicken and egg scenario. Developers need a large user base to justify building killer apps, and users need compelling apps to justify buying the hardware. Third, there's the cost and accessibility factor. These devices aren't cheap, and that's a big barrier to mass adoption. Until the price point comes down and the tech becomes more accessible, it's not going to hit the mainstream in the way smartphones did. Finally, there's the social and cultural aspect. Wearing AR glasses or VR headsets in public still feels awkward and intrusive to many people. Until we crack the code on making these devices feel natural and integrated into daily life, adoption will lag behind. In essence, spatial computing's potential is still there, but the tech ecosystem and cultural readiness have to align before it becomes the transformative tech everyone's been predicting.
Interesting. Anywhere else you would like to drive this conversation moving forward? Some interesting area.
All right, let's pivot to something that might be equally intriguing: the intersection of AI and sustainability. As much as we're dazzled by tech advancements, the looming environmental challenges are getting more urgent. One fascinating area is how AI can drive sustainability efforts. We're talking about optimizing energy grids, predicting climate patterns more accurately, reducing waste in manufacturing, and even enhancing precision agriculture to feed a growing population without wrecking the planet. The global AI and the green tech market is forecasted to hit around $18 billion by 2027, showing there's real momentum here. We could also look at the ethical implications of AI. As AI becomes more ingrained in our lives, the questions about privacy, bias, and decision making become more pressing. It's one thing to have powerful tools, it's another to ensure they're used responsibly and equitably. Or we could dive into how education itself is being transformed by these technologies. Personalized learning, adaptive tutoring systems, and even AI driven career guidance could reshape how people acquire skills and stay relevant in a fast changing job market. Any of these directions sound like a rabbit hole you'd want to explore?
Nope. I would like to come back to this entire student perspective of learning AI and all these things. What do you think is the future of development moving forward? What do you think development will change? And I for sure know that the answer is yes of that. But how will development change in when AI comes in? Do you think the number of people required in development will be less, will be reduced, or do you think there'll be new streams, etc., etc.? What is your opinion?
Yeah, development's definitely going to evolve, and AI is going to be a massive catalyst for that change. Here's how I see it playing out. First, the number of people required for routine coding tasks will likely decrease. With AI handling the grunt work, fewer developers will be needed for basic coding and bug fixing. Instead, the emphasis will shift to roles that require more creativity, critical thinking, and domain specific knowledge. Think of developers as more like architects or strategists, directing AI tools to build and optimize complex systems. Second, we'll see the rise of new roles and specializations. For example, prompt engineering is already becoming a thing, knowing how to effectively communicate with AI to get the desired results. There will also be a growing need for AI ethicists, system integrators, and people who can ensure these tools are aligned with business goals and ethical standards. Third, the development process itself will become more iterative and experimental. With AI assisting in rapid prototyping and testing, developers can try out more ideas faster, leading to more innovative solutions and quicker iteration cycles. This could democratize development, making it easier for smaller teams or even solo developers to create impactful products. In the end, development will become less about writing lines of code and more about orchestrating intelligent systems. It's not that developers will be out of a job, rather, their jobs will evolve into more strategic, high level roles where understanding the big picture is key. It's like moving from being a bricklayer to an architect.
Okay, fair. Now let's end this conversation along with 10 news that you think are very relevant for a student studying AI ML in this current economy. What do you think are the next 10 big news that affects a student's career?
All right, let's wrap this up with 10 key news items that are super relevant for students diving into AI and ML right now. First, major AI advancements. Breakthroughs like GPT 4.0 or other state of the art models are continuously pushing the boundaries of what AI can do, making it crucial for students to stay updated with the latest tech and methodologies. Second, AI regulations and policies. Governments around the world are drafting and enacting regulations on AI use. Knowing these laws and ethical guidelines will be critical for anyone in the field. Third, AI in healthcare. The rise of AI in healthcare, from diagnostics to personalized treatment plans, is creating a huge demand for AI savvy professionals in the medical field. Climate tech and AI is being leveraged to tackle climate change, from optimizing renewable energy usage to predicting environmental impacts. This is an area with massive growth potential. Fifth, job market shifts. The tech job market is evolving with a growing focus on roles like AI ethics, machine learning operations, and AI security. Staying ahead of these trends can give students a competitive edge. Sixth, AI and creativity. Tools like DALL-E and other generative models are transforming creative industries. Knowing how to leverage these tools can open up new opportunities in design, media, and entertainment. Seventh, open source AI frameworks. The proliferation of open source AI frameworks like TensorFlow, PyTorch, etc., means students can access cutting edge tools for free, leveling the playing field and encouraging innovation. Eighth, AI in education. The integration of AI into educational tools is changing how people learn, offering personalized and adaptive learning experiences. Ninth, AI ethics debates. The ongoing debates around AI ethics, especially regarding bias, transparency, and accountability, will shape the future landscape of AI development and deployment. 10th, interdisciplinary collaborations. The growing need for AI expertise across various fields means that students should prepare to collaborate with professionals from different domains, enhancing their adaptability and impact. Staying on top of these trends will not only keep students relevant, but also position them to capitalize on the next big opportunities in the AI landscape.
Okay, thank you, Chad, for joining in. That is it.